In this video, we will talk about trees. This is a very important topic. You should be able to understand the different structures of a tree and how to traverse it. Let's define trees first. A tree is an acyclic graph that contains a collection of nodes. Each node has some data and a reference on the following nodes, which we are calling children. A tree has a root, which is at the top of the tree. The root node does not have any parent. The bottom nodes are called leaves. A binary tree is a tree where each node has 0, 1, or 2 children. Since there is a maximum of 2 nodes, we refer them to as the left node and the right node. Now, a binary search tree is a sorted binary tree. Each node should have its right side with a smaller value than the current node's value, and its left side values greater than the current node's value. Can you guess which one of those trees is not a binary search tree? Actually, the right tree is not a binary search tree, as the node 2 here is smaller than 3. To be a binary search tree, this node should be greater than 3, but smaller than 5. So now let's see the different ways to search a node in a tree. The first way is called depth first search, or DFS. There are 3 ways to traverse a tree using a DFS. First one is in order. For in order, we are recursively exploring the left side first. Then we look at the current node, and then we look at the right side nodes. As you can see in this example, we would have D, then B, E, A, then we'll go to F, C, and J. Then we have pre-order traversal. In this case, we are looking at the current node first, and then recursively exploring the left and right sides. And in this example, we would have A, B, D, E, and then we'll go back here to C, F, and G. And finally, we have post-order. For post-order traversal, we recursively look at the left side, then the right side, and we'll finish with the current node. In this example, it will mean that we will go to D, then E, then B, and then F, J, C, A. Whichever traversal we are using, the complexity in terms of time is O of n, since we are looking at all the nodes. And the complexity in terms of space will be the depth of the tree, as we use the recursion, and we are counting the space used by the stack. The other type of search that we can use is called breadth first search, or BFS. In this type of traversal, we explore all nodes in one level before going to the level below. With the example that we have here, we will have A, B, C, D, E, F, and G. Since A is on level 0, we look at it first. Then we are looking at level 1, where we will have B and C, and so on. It is possible to use recursion to traverse the tree with BFS. but the time complexity will be O of n squared, since we have to go back to the previous node to look at other nodes in the same level. While if we are using a queue, the time complexity will be O of n, as we would explore the tree only once. In terms of space complexity, both have the same complexity, which is O of n. So if you have to traverse a tree using BFS, use a queue.